Okay, so this is the online lecture for binomial expansion. So basically, binomial expansion, we are going to turn something like a plus b to the power n into a series. So you guys will have seen things like this. GCSE, you will have done a plus b squared, and you will have expanded a plus b cubed using that strange kind of smiley face method where you times out each bit of your brackets. That's great, but we need a general way to do this. That method would get very tedious to powers of n greater than 3. The way we're going to do that is the binomial expansion. So there are 3 different methods we can use for binomial expansion. First method is Pascal's triangle, which I view more as an emergency method if the other 2 methods fail or if you forget them in the middle of the exam. Next we have the NCR method, which comes from statistics and basically works out the number of ways you can arrange different things. And then lastly we have the binomial theorem, which is an equation that they give you in the formula book. It's quite easy to use, and you guys will need to use it next year in Core 4 as well. Okay, so we're going to get started with the NCR method. Okay, so NCR method. You guys will have expanded something before, like 5 plus 3 to the 3x at GCSE to the power 2. When you do that, imagine you would have gone 5 plus 3 to the x, written out the second bracket as well, and then expanded it. So we'll have done something like 5 times 5, get 25, 3x times 5, get 15x, 3x times 3x, got 9x squared, and then done your 5 times 3x and got another 15x, and then simplified to give you 25 plus 30x plus 9x squared, which is brilliant. The method works well for things to the power 2 for quadratics. Where it doesn't work so well is if you've got greater than a power of 3. That's why we're going to be using this binomial expansion. So the 25 and the 9x squared are pretty self-explanatory, pretty obvious. When you square 5 you get 25, when you square 3x you get 9x squared. However, the other two, 15 and 15x, are the ones students often forget, and the ones that are a little more difficult to work out what the coefficient is going to be in front of our x term. That's why NCR is useful. NCR comes from statistics. It tells us the number of ways of choosing r from a group of n things. And it's given by the following equation: NCR equals n factorial divided by n minus r factorial times by r factorial. Alternatively, you can look on a calculator, find the divide button, hit shift, and you'll find a button that says NCR. We just hit number, hit NCR, and then hit your R number, and it will tell you the number of ways of arranging that group. So why is that useful? Well, if you've got something like a plus b to the power 6, and we want to expand this, we can probably assume that the first term is going to be a to the power 6. Just as if you imagine writing out this bracket 6 times and multiplying all the first numbers together, you'd get a to the power 6. But we also need to work out what the coefficient is going to be out the front of that number. So by using 6, choose, and then 0, because this is our first term and there's no b terms in this, multiply that by our coefficient, multiply that by our a value, we can then find our coefficient. So 6 choose 0 is actually 1, so we get 1 times a to the 6. We can do this for each one of our terms as shown, and get the series as follows. So each of these terms in our series is going to be added together. We just need to evaluate what each one of them is. So just a few things to note. When we've got 6 choose 1, we're going to have all of our b and our a terms. The total powers there have to add up to 6. The 1 there refers to our b term. So we look at the next one. 2 there refers to our b term is squared, and 4 and 2 will give us 6. If we go to our very last term, we're going to have power of 6 for b, nothing left for a, and then adding up to 6 again. So it's just a way of quickly checking you've got everything right. Another thing I've noticed students do as a mistake is they put these addition signs in between these, which doesn't actually make any sense. So 6 choose 1 is the coefficient, the number in front of a. It's not a number plus a, it's how many terms there are that have a to the 5 and b to the power 1. So if you look back at the earlier example, 5 plus 3x to the power 2, we need to work out how many of these terms do we have a x and a 5 term, and that will just be given by 2 choose 1, 2 C1, which will equal 2, and that will tell us that there's 2 terms of 15x, which we know there are because we get 30 in the end. So it's that kind of idea again, but we're applying it to a greater power. Anyway, you can use a calculator to evaluate what 6 choose whatever is, and then we can just fill in our coefficients for our expansion. And there we go. Always remember though, even if you write it out like this, you need to write it out in terms of a series at the end. So your final answer will look like this, which barely fits in the screen. So a to the 6, 6a 5b, and so on and so forth. So that's what your final answer should look like. Okay, so we'll go back and do a proper example of this with numbers and x values in later. But we're going to move on to the Pascal method, method number 2. So the Pascal method is very, very similar. The only difference is you don't need to use NCR anymore. We can use Pascal's triangle to tell us what the coefficient is going to be. And I would say this method is the impending doom method. By that I mean if you've forgotten NCR, you've forgotten the binomial theorem, this is the method you can use. So you've still got those marks, although it might take you a little bit longer. So the idea is we can write out Pascal's triangle, there you go, and so on. In case you haven't drawn Pascal's triangle before, you're basically adding the two numbers above to make the number below. So this row would be 1, 6, 15, 20, 15, 6, and 1. And each of these rows relates to the NCR numbers that we worked out before. So if we wanted C choose 3, we can look at the row relevant to 6, which is there, and we'll have 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3 will be equal to 20. So it's exactly the same method as before. Instead of 6 choose whatever, we are going to just look at the triangle, find out the row we want, and each of these is going to be our coefficient. So let's give it a go. If you guys could give this a try too, maybe pause the video and see if you can do it yourself. We're going to try and expand 3 plus 2x to the power 4. Okay, 3 plus 2x to the power 4, so I'm going to put Pascal's triangle here as well, just so you can use it for reference rather than have to write it out yourself. And that's as far as you should need it for this. If you want to pause the video now and give it a go, and then we can check answers and methods in just a second. Okay, so I'm going to use the NCR method to do this, just because I think it's a little bit clearer and it's probably the one that students have most trouble with. So let's go for our terms of our expansion. So the first term, we're going to get 4 choose 0 times by 3 to the power 4 times by 1. We don't have another value there. So that's our first term in the expansion. Next term, put a plus sign there. It's always easy if you draw it in a column and then sort it out at the end. We're going to have 4 choose 1 times 3 to the power 3, so the power is decreasing by 1, and we also have to multiply that by 2x. I always put the x bit and the coefficient in brackets, because if you've got a negative number, things can go very, very wrong otherwise. So let's fill in the rest of this. Okay, there we are, so all filled in. Now we just need to evaluate what each of these terms is and write them in a series below. So 4 choose 0 is going to give us 1 times by 3 to the 4, so we're just going to get 3 to the 4, which is 81. Next term we're going to get 4 choose 1, which gives us a 4, multiplied by 3 cubed, multiplied by 2x, so you should get 216x there. It's normally the third term where if it's going to go wrong, it does go wrong, and that's because we now have to treat these brackets properly. So 4 choose 2 is going to give us a 6, 3 squared a 9, and then we have to square everything inside that bracket. So you should be multiplying by 4x squared. So the whole coefficient for this one should be 216x squared. Okay, if you got that one right, brilliant. The rest should be fine, so let's fill in the rest of that row. And that is what your finished expansion should look like. Okay, so if you didn't want to work out what the combinations are on your calculator, you can just say the first one is going to be 1, your next one is going to be 4, 6, 4, and 1. And just be careful what I said, make sure you put those brackets in so that everything in there is squared or cubed or whatever. Okay. Okay, so let's do one more example. So I'd like you guys to give 5 minus 3x cubed a go. Be careful with the brackets on this one, that's the only hint I'm going to give you. And I'll give you a couple seconds and then I'll show you the solutions. Pause the video if you want to give that one a go. So the solution should look like this. So there's your working to your final solution, and when you stuck that all into your calculator you should get the following. So 125 minus 225x plus 135x squared minus 27x cubed. So check you got that. If you haven't, have a look for your workings, make sure your brackets and your negative signs are in the right place and that you've used the right combination for your answers. Okay, before we move on to our last method, which is the binomial theorem, I just want to talk about coefficients. Exam papers love asking about coefficients, and there's two kinds of past paper questions I just want to go through very quickly. So, coefficients are the number or the thing, it could have a letter in it, in front of the x. For example, if we had 5x, the coefficient of x is 5. If we had 125kx cubed, then the coefficient is going to be 125k. Coefficient of x cubed even is going to be 125k. There we go. Okay, so what they can do in past paper questions is give you an unknown instead of an x, or give you something unknown in your expansion, tell you the coefficient of one is equal to, say, 2 times the coefficient of the other, and ask you to work out what that unknown is. So, really simple example, if we got kx and 25x squared, and we are told that the coefficient of x is 1/5 of the coefficient of x squared, is obvious then that k would be 5. So coefficient of x, 1/5 of the coefficient of x squared, well then you know that k has to be 1/5 of 25, which is going to be 5. So there's one question they quite like to ask, comes up quite often. Another more difficult question is to find some possible a values. So let's have a look at this one. Okay, so here's a past paper questions. Find the first 4 terms of ascending powers of x, the binomial expansion of 1 plus ax to the power 7, whereas a constant, give each term the simplest form. When you've done that, given that the coefficient of x squared in this expansion is 525, find the possible values of a. So I'll leave you guys for a couple of minutes to try and do the first 4 marks of that, and then we'll talk about part B. Answers coming up in a couple of seconds, so pause it now if you want to do part A. Okay, so you should be able to get the result 1 plus 7ax plus 21a squared x squared plus 35a cubed x cubed. Okay, so we are told that the coefficient of x squared is 525, so that's talking about this coefficient here. So the coefficient of x squared is 21a squared. We're told that the coefficient is equal to 525, so that has to equal 525. So we could divide each side by 21 and find that a squared is going to be 525 over 21, which is the same as 25. So if we want the possible values of a, just be careful here. They said possible because it's positive and negative. Both those values are possible. So a is going to equal plus or minus the square root of 25. So a equals 5 or a equals minus 5. Quite a nice 6 marks there. So just be careful with that. Make sure you're happy understanding coefficients and being able to equate them in a question like this. Okay, so last bit, binomial theorem. You're given this in the formula book. I've written it out there below, and it basically goes on forever in the same kind of way. So the next one will be n minus 1, n minus 2, n minus 3 over 4 factorial x to the power 4. Key things to note, this is only for the very special case where you've got 1 plus x to the n. They won't always look like that. We'll come on how to deal with that in a minute, but for this special case, that is how you do it. There is a way, however, to make this a little bit easier. So wherever it says x, so there, and there, I'm going to change that into blue capital X. Magic. Okay, so blue capital X. The reason for this is because sometimes blue capital X could equal something like 2x. In that case, it becomes a lot clearer if you're dealing with kind of a variable and a value rather than just your weird x values. Okay, so let's do an example of this and you should be able to see why it's easier to use blue capital X. Okay, so if you want to expand 1 plus 2x cubed, we can do that using the binomial method. So I know we could do this using Pascal's or NCR, but with this method the beauty of it is that you just have to substitute things into the formula, and this is actually a lot more like some of the other expansions that you might do if you go to do maths at uni or further maths or, for example, physics. So it's similar, you're just subbing stuff into this equation. So in this case, blue capital X is going to equal 2x. Equals 2x. We've got n equals 3 as well. So given all that, we can literally now just substitute everything in. We just again have to be very careful about brackets and make sure that wherever blue capital X is squared, we are squaring all of that bit there. So let's rewrite this with our terms inside it. And there we go, so I've coloured everything in, so you got x is going to be 2x, so just make sure you are always keeping that in brackets so that square affects the 2 as well, and n equals 3, just sub it in. So when we've got all that together, we can just go through that term by term, expanding, and then write out our full version of it. There we go, 1 plus 6x plus 12x squared plus 8x cubed, and that is a lot faster and easier than having to mess around with combinations or with our Pascal's triangle. Okay, we're going to do one more difficult example which kind of links more into what we're going to do next year in A2, and we're going to try now to expand 3 plus 2x to the power 3 using this method, not either of the other two. So why this is difficult? Well, our method is only for expanding 1 plus x to the n, which this doesn't look like, so we need to turn this into something that does look like 1 plus x to, in this case, the power 3. Okay, so how are we going to do that? We're going to divide all of our terms inside the brackets by 3. So we'll end up with 1 plus 2 over 3 x to the power 3. Because we divide that by 3, we're going to get a factor of 3 outside the front, and because we pull that outside the brackets, we have to cube that 3 as well. Let's put that in brackets first to make it nice and neat. Okay, when you got this done, in this case we're now going to have big X will be equal to 2/3 little x, n is going to be equal to 3 again. All we have to do that's different is after we've expanded all this stuff, we have to multiply it by 27. So could you guys give that a go? Expand this one and multiply every single term by 27, and you should find the expansion for that one. Give that a go now. Okay, if you've done that correctly, you should end up with 27 times by your expansion, which will give you 1 plus 2x plus 4/3 x squared plus 8/27 of x cubed, and we can just expand that out quite quickly. 27 plus 54x plus 36x squared plus 8x cubed as our final expansion. There we go, brilliant. Okay, so we've got one more thing we're going to do today, which is about approximations, and these are very, very common in Core 2 papers. So let's go back and get some space at the top. Okay, so substitution approximations. So the idea is these are normally second parts of questions. So the first bit of the question could be something like find the expansion, or find the first 4 terms of 1 minus x over 10 to the power 6. So you do that using one of the 3 methods we've looked at today, and you'd find that the first 4 terms are 1 minus 3/5 of x, 3/20 of x squared, and minus their x cubed over 50. Okay, so typical part B of one of these expansion questions. By substituting an appropriate value for x, find an approximate value to 0.99 to the power 6. So basically we need to get this thing here looking like this thing here. So we've got to pick an x value that will make the inside of our original bracket into 0.99. So some of you might have seen that already. So we've got 1 minus x over 10 needs to equal 0.99. Very easy to solve. You can just find that x has to equal equal 0.01. So that's the first bit of the question, worth a few marks. But what we need to do though is put x equals 0.01 into our expansion, and that will give us an approximate value for the bit they're asking for there. So let's do that very quickly. So we're going to end up with 1 minus, so we will end up with 1 minus 3/5 0.01 plus 3/20 over 0.01 squared minus 0.01 cubed over 50. And you can stick that right into your calculator and you should find that this expansion gives us 0.94148 and then a few more decimals on the end. And that there is an approximation, so it's roughly equal to 0.99 to the power 6. What they could also ask you at the end of this is to say how accurate this approximation is. So you can just check the value in your calculator, type in 0.99 to the power 6 in your calculator, and you'll find a very similar answer. You'll get 0.94148, and at this point the numbers will start to diverge a bit, so diverging there. So what you can say from that is that your approximation is accurate to 1, 2, 3, 4, 5 decimal places. Okay, that's it for today's lesson then. Hope you guys enjoyed that. It was pretty fun to make. Could you then just do this question and fill in the survey? So this question is to check you've done the work, and if you do the survey, one of you will be winning an Easter egg to say thanks for doing this extra bit of work for me this week. So question to you guys for homework: what is the coefficient of x cubed in the expansion of 3 minus 2x to the power 6? You can use whichever method you're most comfortable with. I'd rather you didn't use the Pascal's triangle though, as it does take quite a while. I'd rather you practice NCR or the binomial theorem method. So if you guys can expand that, find out what the x cubed coefficient is, and then fill in the survey on the bottom of this page, that would be brilliant. Constructive criticism would be great. Any feedback, anything you think I could improve, ways to make this better, and maybe comment, would you actually use this? Do you think if I did this over Easter, you guys would use this for revision? Cool, thanks, and have a good Easter, guys.